how we can achieve, or can we achieve 100% on a RAG benchmark? Uh, so those of you who are new to the AI space and might be wondering what RAG is. So RAG stands for Retrieval Augmented Generation, which is kind of like a short concept where you kind of get external data, or like augment the question that you have with external data, and combine it, like basically augment your question with that data, and then ask the LLM to give you an answer. And you need to do this usually because LLM is not trained on, say, private data, or data that you think is like very specific to your domain. So instead of like hoping that it gives answer on something that is not at all trained on, you would rather like just give it that context directly into the prompt, and try to get an answer. So, so what is this benchmark? We're talking about getting 100%. So, understanding the benchmark is really important. So, this benchmark is called frames. This is something that was released mid to late last year by Google. It stands for Factuality, Retrieval, and Reasoning Measurement Set. It has about 800 questions on the Wikipedia domain. So ideally, like all questions which are in frames can be answered by looking at some articles actually on Wikipedia. And the questions are like very interesting, right? Like it's not like straightforward, like asking for a simple fact. There's a lot of like reasoning involved. It involves like reasoning over multiple articles and so on and so forth. So it's a complex benchmark. So many of you might have heard of DeepSeek, which is causing the waves right now in the AI world. Uh, and DeepSeek also published their results on frames here, along with other popular LLMs. And we can see that uh, frames is it's the results are not bad for any of the LLMs, but it's not near 100% as well. Um, so this shows that frames is a relatively difficult benchmark, and also something that LLMs are looking at to like solve or evaluate against. So how did we evaluate this benchmark? So a little bit of like context on the setup is crucial for you to understand how we did it. Frames paper actually does not describe the setup very clearly. So you might have to like do your own setup, but the important fact is that you use the same setup across each of the LLMs, right? So the setup remains the same, and the LLM keeps changing. So that makes it fair. So the way that we did it was fetching the Wikipedia data, like directly scraping it off, and then doing a parsing. All that is available in this repo, in this code as well. Then we did a vectorizing of the title of each article, and then stored it in Postgres. And in Postgres, you can use PG vector to like store vectors. We also tried just vectorizing the entire content itself instead of the title, but that did not do well in any of the benchmarks. So I think using the strategy of vectorizing the title seems to be generally much better. Then we have to create a function which can fetch like the top K articles given a user query, right? So it will basically do a vector search, do some scoring, and retrieve the top 5. Now, once you have such a function, you can add it as a tool in a RAG program, right? So tool is another AI concept. It's given by most AI services, where apart from like just giving the prompt, you can also give a bunch of tools which the program can choose to run it if it's required, right? The same thing can be just the same function as it is can be added as a command in PromptQL or in Hasura. If you use Hasura, you might be familiar with the concept of commands. So you add that as a command, and the tool functionality or the search functionality is same across all these different programs. So the first thing that we compared against was how did this benchmark perform on naive RAG. So what is naive RAG? As I mentioned in the beginning, like basically when you give a user prompt, it would first do a semantic search, maybe retrieve like top 5 articles. It will combine the user prompt and the articles in the prompt. Just like the question will be the first line, and then all the retrieved content would be the subsequent line. And then it will just ask it will give that to the LLM and ask for a response. As simple as this, right? So this is the naive RAG setup. So it's only doing semantic search once. So frames is going to perform poorly on this by design because all the questions are meant to be like multi-hop, and I don't think there's even one question which can be answered by just one article. Uh, and then the questions are not it's not very explicit, right? Like what data you want from which article and so on. So there is an interdependency, so you can't pre-retrieve all the information in one shot for a given question. uh, you need to use something, you need to calculate something in the first article to then do a subsequent search for other articles. This is where agentic RAG comes in. This is a kind of a new phrase, but still, I think quite popular already. Which is that instead of doing this one-shot kind of retrieval, we make the LLM itself decide when to call the search function and how many times ever also, right? Like, so if you look at this flow here. So when you give the user prompt to the LLM, and this is where tool calling functionality in the LLM helps you like implement this easily. So whenever you give a user prompt to the LLM will decide, oh, does it need some information to answer this question? And if it's yes, then it calls that semantic search function, which gets you the top 5 articles, gives it back to the LLM, and the LLM decides as a next step, does it need even more info, right? And if it's yes, then that goes again, the whole cycle repeats. It will get the new information, augment that again, so on and so forth, right? At some point, it will say, okay, I think this is enough, and it will generate the final answer. So this is agentic RAG. Agentic because the decision to ask for more data or retrieve more data is done by the LLM itself. So this was agentic RAG. So let's look at how this basic setup works with PromptQL, right? So we give the question as it is from the frames benchmark to a naive RAG setup, to an agentic RAG setup, and to a PromptQL setup. We used around 50 questions for this one. Naive RAG actually around like 4 or 5, and it's not showing up here. Agentic RAG was around like I think around 41, 42, and PromptQL was hitting around 50, right? This is what was happening, and it's not very surprising, right? Because what agentic RAG is doing is probably the best thing that you could also think of doing, right? And PromptQL only slightly improves on this setup because of the way that it stores the retrieved data and how it extracts information and so on. But the overall logic is not very different, right? Especially if the context size is not too large. For example, it's only retrieving like 3 articles from Wikipedia, so on. There's not going to be like much difference in calculation. So this is what happens. So what is this about? Like, we are here to like understand how to get this to 100%. So how do we do that, right? So first, let's look at the frames questions itself. So here's a sample of frames questions. Uh, the first one looks like, reads uh, like a complicated puzzle. If my future wife has the same first name as the 15th First Lady of the United States mother, and her surname is the same as the second assassinated president's mother's maiden name, what is my future wife's name? Wow, like it's very hard to like parse something like this itself, right? Let alone like ask LLM to like retrieve related data and give an answer. The second and third question are also similar. The third question is slightly more straightforward, I think. As of 2023, how many more employees is the company which is alphabetically the first by ticker symbol, have then the company, which is alphabetically second to last by ticker symbol. Still little bit of a puzzle like nature, but more straightforward, I think. So LLM already has this concept of like thinking and creating like a chain of thought. So whenever we give this question to the agentic RAG system or to PromptQL, it obviously does some thinking and figures out a plan to like execute it. But obviously that is falling short. We are only hitting like 40 to 50%. So we thought of saying, okay, let's give this question like a better prompt, which is more realistic, which is what a human being in an enterprise or anywhere would actually describe uh, this task as. Nobody is going to ask questions in such a complicated and intertwined manner. They're probably going to ask it in simpler phrases, right? So, for example, for that third question that we saw, you might give an explicit plan which looks like, okay, for this question use this plan, like find the article that contains the S&P 500 list, then get the company name of the alphabetically first ticker from the article, then get the company name of the alphabetically second to the last ticker, and then get articles about these two companies and get the employee count, right? So this complicated question, and rather like a very puzzle-like question, we have just broken that into into an explicit plan. And then we thought, okay, let's see if this removes the kind of let's say the plan component of the LLM. If it removes that, and is it then able to like answer from the retrieved data, right? That was the intent. So here, what we did was give, like for each question, we give a plan. So this whole thing becomes like the prompt. And then we give it to both the agentic RAG setup and also to PromptQL setup. And this is where the magic comes in, right? When we use this, when you use the top 10 hardest questions that we found in the set of like 200 that we sampled, like the hardest 10 we got around 100. In the top, with a set of like 50 questions, we got like 98% accuracy, and so on, right? uh, and agentic RAG with plans is somewhere around 60 percentage. uh, and this is the way to get from like 50 40 to 50% to like 100%. Just give it some reasonable plan and hope that the LLM or your system is going to like be able to like follow that plan accurately. PromptQL does that accurately, as can be evidenced, but agentic RAG still falls short, even though both PromptQL and the agentic RAG setup are using the same LLM. Agentic RAG is not able to follow the plan or execute the plan in a reliable way. So that's where we come to like why is this happening, right? Why is the agentic RAG not able to do accurate plan following and accurate execution of the plan? So let's do a quick discussion on the various cases why agentic RAG fall short. Now, if you look at if you look at the failure modes here, right? One of the most common things that we saw was there was extraction errors in processing, which means that if you give a question like this, it'll do some thinking, it'll say all the right things, except it'll get the actual fact of it wrong. So it says like here your future wife's name is going to be Eliza Balu, but that is the wrong answer. The right answer is Jane Balu, right? And what happened here was because there's so much data in context, right? Trying to extract something which is very similar, like for example, uh, it extracted like the 16th first lady's name instead of the 15th first lady. That is probably because they are very close to each other and whatnot. And the context is already very huge, and there might be like repetitions of the same names here and there. So it's basically very unreliable to extract something very specific from a large context window, right? So that's one of the reasons why extraction fails, and hence the subsequent query fails. With PromptQL, the way extract happens is in a completely different context. There is a smaller, um, like the context size for whatever needs to be extracted is separate from the rest of the context of whatever has happened so far, right? So the context size is smaller. It's able to extract much better using that method. The second is, although this was we like excluded most of these cases from the sample set that we used, but we still kept one or two just for illustrative purposes. Is context size limitations itself, right? So with we are using Anthropic Sonnet here, and for few of the questions like this one, it had to retrieve like 3-4 articles, and hence exceeded the context size. Then we look at one of the more, in my opinion, the most common error when using context size computation is in inexhaustive computation. What does that mean? So if you look at a question like this, uh, which is basically like asking how many people had walked on the moon on, as of the first model year of the vehicle. So if there are multiple answers, like if there are like different parts to the answer, and then you have to collate the answer as a whole, the LLM is actually generally very quick to like answer as soon as possible, right? So usually it answers like only 2 people have walked on the moon, although there are 4 people because they were like 2 different missions with 2 people each. But what the LLM usually does is, as soon as it has got some inkling of an answer, it's very quick to like just respond with that, and not finish the whole. It does not like do like a proofread of its solution and check if it's done things exhaustively. This is where PromptQL again shines, because PromptQL is designing like a plan for this, and it's executing the plan more precisely. So it's not stopping midway whenever it feels like it has got some answer or something that resembles the answer. It's actually computing the whole thing according to the query plan and then finally giving it answer, right? Um, and finally, the usual issue with LLMs is like it cannot compute things properly, right? It doesn't have a mathematical or computational engine. So hence, like few questions go wrong there. But with PromptQL, you do have a computation engine, so these things don't happen. So these are the reasons because of which we are able to achieve like 100% on a subset of the frames questions. We would love if you could try it out on your own setup, bring your own unstructured data, vectorize it however you want. It's like few clicks, a few commands to like get it set up with PromptQL and to start using it. So with that, I will stop and take any questions in the chat.
Awesome, Tibor. Thank you so much. So we do have one question that's over here in the Q&A section already, which I think Harsha is going to put up on the screen for us so everybody can see it down below. It's a little bit long, so I'm going to go ahead and start reading it out loud. It says, if I understand what you're adding to the context in this flow is the whole Wikipedia article, why not chunk the article and only search part of it to reduce context size?
Yeah. So the two reasons for that. The first reason was we did try that, and across all the systems, the results were very poor, and that is actually a good indication of the frames benchmark, that it needs chunks which are like spread across here and there, and there is interdependency and so on. So using the chunk, like small chunk strategy, did not work out in any case, right? It was poor for all the systems. And then we looked at the chunk size for Wikipedia, each article basically, and it seemed like it should be fine to like give the whole article itself to the LLM and not worry about chunking strategies and lose precision because of this artificial reason. And unless 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 the number of articles explodes a lot, which like goes around 10 plus or so on, or the LLM actually does or does not retrieve the articles more efficiently and just like overloads the context for no reason, only then we see context size limitations. Otherwise, with just the ground truth Wikipedia articles, if you compute that, 99% questions should fit into the context.
Awesome. Very helpful, as it's being said in the chat over there. And yeah, it's a lot of fun to see how context size is changing in all these LLMs as well. There's one more question in here, and I think this may come up a little bit later on when Praveen's demoing some of the product updates that we've had, but in particular, the questions around the query planning. So does it work step by step in a while loop is the question.
Yeah, so think of it as having a complete execution of a program inside. So it does have a while loop. So behind the scenes, it's a Python runtime, right? So everything is happening inside, and there is like interfacing with something that we call memory artifacts and AI primitives and so on. So it's like a whole runtime of like executing a plan reliably.
Awesome. I've got one more ask for you on your way out as you go backstage. Somebody's asking for the getting started for the PromptQL docs. So if you wouldn't mind dropping that in the chat for everybody so they have access to it as well and can get started themselves after this call is over. Thanks so much, Tiro.
Thanks, Rob.